Hello, good day, viewers. Still on NECO 2024 Mathematics Examination Theory questions. Here is question number 11, which is under geometrical construction. But at the moment, my mathematical set is not ready. Therefore, we have to move to question number 12. And question number 12 is under statistics. We are giving scores of students here in tabular form. We have the marks in percentage. We have the frequency. We're asked to compute for the mean, the median, and the mode. All right, the first thing you need to do is to recompute the table here in this manner. You can see we have X, F, Fx, Cf, LCB. X here stands for the midpoint. The midpoint is nothing but the average of every single class limit here. F stands for the frequency, which is given already. Fx is the product of the midpoint X and the frequency. CF stands for the cumulative frequency. LCB stands for lower class boundaries. All right, let's start with this first one, X. To find X, we have to take average of every single class limit. Let's start with the first class limit, 1 to 10. The average will be 1 plus 10 divided by 2. 1 plus 10 is 11, and 11 divided by 2 will give us 5.5. So we write 5.5. The next one will be 11 plus 20, which is going to give us 31, and 31 divided by 2 will give us 15.5. So we have 15.5. But what you should understand here is what is the class size. The class size will always be this minus this, this minus this minus this. You can see that? Or this minus this minus this. In either way, you have to get 10. So the class size is 10. So you can keep on adding 10, 10, 10 here. How many do we have? 1, 2, 3, 4, 5, 6. So in 6 different places. So you can see that this plus 10 will give us this. And once you add 10 to this one, it becomes 25.5. 25.5. Add 10 here, you have 35.5. Add 10 again, we have 45.5. And lastly, we have 55.5. Then we need the frequency, which is already given. We have 26, 36, 38. 26, 36, 38. 30, 15, and 5. 30, 15, and 5. Then we need to take the product of X and F. Let's start with the first one, that is 5.5 multiplied by 26. That is exactly 143. Then you take this one, you multiply, you have 15.5 multiplied by 36. That is 558. 25.5 we multiply by 38. That is 969. We take the next one, which is 35.5 multiplied by 30. That is 1065. Then we take 45.5 multiplied by 15. That is 682.5. Then lastly, we have 55.5 multiplied by 5. That is 277.5. Then cumulative frequency. The first cumulative frequency is equivalent to the first frequency as always. So you write 26 here. Then you take this 26, you add it to 36. That's going to give us 62 exactly. Then you take 62, you add it to 38. That will give us 100. Then you take 100, you add it to 30. That will give us 130. 130 plus 15, that is 145. And lastly, 145 plus 5 is 150. All right. Then lower class boundary. To find the lower class boundaries, we have to subtract 0.5 from every single lower class limit. So if you take this one, you subtract 0.5, you're going to get 0.5. Take the second one, which is this. Subtract 0.5, you're going to get 10.5. Remember, we have the same class size. If you keep on adding 10, 10, 10, because from here to here, we have a difference of 10. So we have 20, we have 30, we have 40, and lastly, we have 50. All right. So we have just finished computing our table. Let's start with the first item here, which is the mean. So Roman number 1, the mean, which is denoted by what? X bar. This is equal to the summation of fx divided by summation of f. All right. This is the last cumulative frequency, 150. Therefore, if you add all the frequency together, you have to get 150. So this is 150. That is the total. Then we need the total of fx as well. So let us add them all together. We have 143 plus 558 plus 969 plus 1065 plus 682.5, and lastly we have 277.5. Altogether we have 3695. This is the fx, summation of fx. So we substitute. This is 3695 divided by 150. If you divide by 150, you're going to get 24.63, but they said to the nearest 1 dp, right? Correct to one decimal place. So we are going to write it as 24.6. We are done with the Roman number 1. Then Roman number 2, we're asked to compute for the median, right? Median. So let's do that. We have a formula for that as well. The median is equal to the lower class boundary of the median class plus summation of f divided by 2 minus cumulative frequency before the median class divided by frequency of the median class multiplied by the class size, right? So let's substitute. First of all, we need to locate the median class. The median class position, so let me say position of median is equal to n divided by 2 position, and our n is 150. Remember, that is summation of f. If you divide it by 2, you have to get 75. So 75th position. So let us locate it using the cumulative frequency. So you have to find out where 75 lies. You can see that this is less than that. This is also less than 75. So it must fall under 100. So this is our median class. All right. So what is the lower class boundary of the median class? It is what? 20.5. Therefore, the median is equal to the lower class boundary of the median class, which is 20.5 plus this divided by 2. Summation of f, remember summation of f is what? 150, and once you divide it by 2, you get 75. Or should we write it all? So let's write it 150 divided by 2 minus cumulative frequency before the median class. So this is the cumulative frequency before the median class. That is 62. So minus 62 divided by the frequency of the median class. This is the frequency of the median class, that is 38. Multiplied by the class size, which is 10. All right, so this is what we have to compute. This is equal to 20.5 plus, this is 75. 75 minus 62, that will give us exactly 13. Divide by, this is frequency of the median class. It should be 38, please, sorry. then multiplied by 10. So this is equal to 20.5 plus 130 divided by 38. So 130 divided by 38 plus 20.5, that will give us 23.92, but one decimal place is 23.9. So this is the median. That is the median score. And lastly, we asked to compute for the mode. So the mode is equal to lower class boundary of the model class plus delta 1 divided by delta 1 plus delta 2 multiplied by the class size. I will explain all of this. Delta 1 stands for the frequency of the model class minus the frequency before the model class. The same thing with this one, right? And this is frequency of the model class minus the frequency after the model class. And this is the class size. Let us locate the position of the mode. Remember, mode is that class with the highest frequency. And you can see that 38 is the highest frequency right here. So it has the same position with the median. So lower class boundary remain 20.5. So this is 20.5 plus frequency of the model class minus the next frequency before the model class. This is the frequency of the model class minus the frequency before the model class. That is 38 minus 36. 38 minus 36 divide by the same thing with this one, right? 38 minus 36 plus this one is the frequency of the model class minus the frequency after the model class, which is what? 38 minus 30. 38 minus 30 multiplied by 10. So this is equal to 20.5 plus 38 minus 36 is 2, divided by another 2 here, plus this is 8 multiplied by 10, right? This is 20.5 plus 2 multiplied by 10 is 20, divided by 2 plus 8 is 10. So you can see that 20 divided by 10 is 2, and 2 plus 20.5 is 22.5. And hence, this is the mode, 22.5. And this is all about question 12, which is our last question in this paper. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.